Csap Kubernetes support is provided by the Kubelet service included in the Kubernetes provider cluster. Note, the package installs several additional services in addition to the Kubelet service. They are defined as OS process monitor services. Note, there is no option to deploy or remove these services. OS process monitors are a convenient mechanism for tracking resource consumption and key performance indicators. The Csap package deployed by the Kubelet service also includes several deployable Kubernetes components that are compatible with the version of Kubernetes deployed. These components are independently deployable so as to enable incremental upgrades. The Kubernetes dashboard, for example, can be updated, deployed, and even launched. Every Csap service may optionally specify a README as either markdown content or a URL to retrieve markdown content. The Kubelet package README shows the components installed along with key configuration settings. The Csap installation screencast include a detailed examination of the Kubernetes installation. Summarized, the Kubernetes installation is written to enable as much concurrency as possible while ensuring the correct orchestration of events. The Cubelet Metrics view provides access to the standard resource consumption graphs. Note, these are specific to the Kubelet OS process, not the Kubernetes containers. The Kubelet definition also includes key performance indicators that include aggregated data across the cluster collected from the metrics server. For example, the CPU core usage on each of the Kubernetes nodes. Note the spike shown during the daily performance test. The Csap Deployment Tab contains two sections, the Csap View and the Kubernetes Summary View. The key distinction is that the Csap View enables examination of all clusters and services defined using the Csap application definition. This includes the ability to perform deployment-related activities. The Kubernetes Summary View leverages the Kubernetes provider defined in the Csap application definition to identify the nodes, volumes, pods, and events. These may be inspected using the Kubernetes APIs or the definitions viewed. Note, the Csap application portal only includes a subset of the Kubernetes resources. The Csap agent portal provides complete access to all defined resources along with the ability to perform ad hoc deployments. To further highlight the distinction between the views, consider the Csap monitoring cluster. It includes a service named Monitoring Tools that aggregates many pods together for management purposes. For example, if we select logs, note that the complete set of logs for all of the services is shown. The application definition enables teams to choose the granularity that works best for them. The Kubernetes pod view shows pod state summarized by namespace. Selecting the Csap monitoring namespace shows the pod instances grouped by specification. Selecting Grafana highlights that pods may be inspected, definitions viewed, and also logs may be shown. Note that Csap includes the ability to customize the log viewer along with predefined templates. This can be disabled if needed. The Performance tab includes several key Kubernetes views. To highlight the real-time performance features, the Kubernetes performance test was started. Selecting the Kubernetes real-time performance view shows the primary resource utilization collected from the Kubernetes metrics server. By default, the views are sorted by CPU utilization. The views may be filtered by pod groups. Pod workflows include the ability to then quickly navigate to the Kubernetes summary view. Logs may be viewed or pod details shown. The Kubernetes Trend view supports both long-term resource planning perspectives as well as short-term troubleshooting. Selecting View by Host will break down the selectric metric. Selecting Node Cores highlights the daily performance test. The Trend view includes a link to cross-launch to the Csap Analytics portal. Shown here is the ability to quickly run analytic queries to determine changes over time. The Container view on the Host tab provides access to the most recent Kubernetes collection from the Csap agent. The Node view on the Deployment tab provides deeper visibility into the Kubernetes deployment state. This is a critical perspective as insufficient resources available for requested deployments or during a failover may lead to Kubernetes continuously attempting and failing to fulfill deployment requests. To demonstrate the deployment of services that use Kubernetes, I'm first going to demonstrate the concept of Csap batch operations. Here we can see we have a Csap cluster called Csap test with several services. To get started, I'll go ahead, switch to the batch operations view, select the cluster, and then select remove. Here we can see the batch operation deployment is shown underway, and if we select the backlog view, we can watch as the services are stopped. The key item to note is that they are stopped according to the start order attribute in the application definition. And each of these services has a orchestration attribute that says wait until the previous service has stopped. Switching over to the service view highlights that all of the services are now in a stopped state. While the batch operations view could be used to quickly start the cluster with the appropriate orchestration, instead, I'm simply going to view the services in start order and then go ahead and click deploy. The container attributes are shown and be modified if desired to upgrade the image. Here you can see the output of the deploy highlights the fact that we have this orchestration job that waits until all of the pod conditions are passed. Clicking refresh on the logs view now defaults to show the container logs. As mentioned earlier, the log view defaults to use Csap log formatting, but this can be disabled if needed. Let's look a little closer at how the active MQ is defined. Selecting the Container tab, we can see the images being specified. But looking at the specifications, note there are no YAML files specified. Instead, this service is being deployed using a generated YAML file. It is generated using the Kubernetes Java API. Let's move on to the next service in the cluster, Postgres. Postgres is a traditional Kubernetes deployment that leverages Kubernetes YAML files. Applications may optionally choose to use Csap service variables in the Kubernetes specs to normalize the deployment artifacts. Once again, we can customize any of the settings during the deployment. And once again, we have orchestration at the end, waiting for all of the pods to be completed. One distinction here is after refreshing the logs, we now see the log output of the service, but now we also see the YAML files. These are the YAML files with any of the service variables resolved. The Csap reference service is a Java Spring Boot application with a generated specification. It is a little bit more interesting because it includes a couple of other key service variables. The ingress variable, which is used when launching the application. The replica count, which is used to increase the availability of both CPU and HA. And finally, the use of the pod IP variable. This is used in combination with Spring Boot Micrometer to access the Csap live view on the agent portal. So let's go ahead and deploy the reference service. So we'll go ahead and click deploy. The standard configuration is displayed and the service is kicked off. The logs view automatically opens and the orchestration output is displayed at the bottom. Once again, highlighting how this is defined. It's simply a job attribute that's associated with the service. Switching back to the logs view, it defaults to the container runtime, which is still starting up. So we'll go back to the deployment tab just to wait until all of those instances are done. And with all instances of the service deployed, we'll refresh the instances and then select logs. This ensures that all the containers are populated in the drop-down. Here you can see we can quickly switch between them. Again, this service is using log4j JSON format, so we can actually enable the detail view to get a few additional fields displayed. Additionally, we can launch the service instance. This is using the ingress URL. Because this is a test service, we can use it to generate traffic. In this instance, we'll trigger a bunch of ActiveMQ messages. In this case, we'll send 100. This should ensure that we distribute the messages across several of the hosts. And looking at the output, we can see all the messages coming through. Let's look at a service with the Spring Boot Micrometer deployed. Now, I've switched to a different lab that had traffic recently run, and you can see the results of those runs being displayed directly in the application console. However, with the Csap Live integration, we can actually go and collect from the pods in real time. In this instance, I've picked a very specific instance of the pod on a host. I filtered it so that we can find the JMS metrics, and we'll choose to display this with both the message count and the distribution of messages. I've returned to the test application and triggered some messages to be sent. Coming back to the live console, we actually see the data being displayed in real time. The Csap agent portal provides access to the complete runtime context of the selected pod. This includes predefined metrics, Java metrics, including subviews such as the Java heap. The application metrics shows the recent load test run on the pods that are deployed on this host. The OS performance view provides access to the host level resources, such as the CPU being used. The file manager defaults to the views defined in the application definition for the service. Here it defaults to the root file system, and we can see the Spring Boot jar that's being deployed and executed. Selecting Show Default Shortcuts will show all of the host file systems that are available, including being able to browse all the running containers on the host. Here we navigate to the same location. The Top++ view combines a consolidated view of real-time data from the operating systems. Items can be selected to view more information. In this case, we launched the socket command, clicked on Run, and then scroll down and we can view the actual open sockets. Returning to the OS Explorer, we can also, for example, click on the parameters and view the runtime information. The OS Explorer view provides extensive integration with Kubernetes and may modify the state using either Kubernetes or Helm APIs. Here we've selected the Csap test namespace, and we're looking at the pods that are available within it. We can select an instance and view the logs. And per previous observations, we can also switch the formatting off. Going down, we can also look at the logs of some of the other services. Here, we open up the Postgres logs, and again, we can enable quick formatting for a slightly more readable format. We can restart a deployment. In this case, we're going to trigger the rolling restart of the Csap reference deployment, which includes 6 pods. And as that occurs, we'll see the events getting updated. And we can see the rolling restart slowly but surely taking effect. And now it's completed. We can actually edit the deployment. In this case, we'll go ahead and change the replicas down to 2 instances. We'll click Update. And there's a couple of warnings, but they can be ignored. And within a minute or so, Kubernetes will shut down the old instance and then start it up again. And again, we're seeing the events that correspond to the activity. And now you can see we only have 2 running instances. Switching to the monitoring namespace, we can see that Grafana has a lot of config maps that define its dashboards. We can look at those through the content viewer and quickly view and or modify the data. You can see the Grafana pod, and of course we can run a quick describe command on that to look at the state of the deployment. Switching to the all namespace, we can run Kubernetes command line. These can be run through the command runner, but sometimes having access to quick CLI output is helpful in the context of the Explorer. Here, we're just demoing the help command, and we can also look at the pods. We can also deploy Ad-Hoc Yaml files using the specification editor. Here I've loaded a sample of an Nginx deployment that creates a new namespace, a config map, some services, and we'll go ahead and click create. You can see the artifacts have been created, and within a minute or 2, the new namespace will be available. With that namespace filter applied, we now see that we have an Nginx simple deployment with a single pod deployed inside. We can use the service to actually launch the node port instance, and so we have a message showing hi from Nginx simple. This is a little bit different from the default, and if you look at that deployment specification, you'll understand why. Here what I'm doing is I'm launching the OS Explorer on the host where the pod instance was deployed, solely so that I can get access to the running container. In this instance, on dev 6, which is where the pod is running, I now have access to the container storage. I'll go ahead, open that up, and per an earlier screencast, the Nginx HTML file is under user share Nginx HTML. And so now we can just double click on the index file to open it up, and we'll go ahead and modify the message. So again, what we're doing is editing a file in a container that's running on a pod, and we just save it to the container file system. We'll go back to our test page, and now we're seeing the modified example. That can be really useful when troubleshooting and debugging your tests. Csap support for Helm includes support for both ad hoc deployments as well as CSAP service template deployments. Here you can see that we can quickly view the Helm deployments on a node and look at any of the release definitions. We can also list out the repositories and run commands. In this instance, the command is simply the listing of the repos and a few other standards. We can also run ad hoc commands using the Helm CLI. In this instance, we can simply run the Helm repo list. You can modify if you need to, and then run. Here you can see that there's only 2 repos on the system. Switching over to the application portal, let's look at how the definition integration works. Clicking on the README will use the output of the Helm CLI command, as will the Helm values. Again, these commands are using the release in the repository defined in the definition, which we'll look at in a few minutes. Switching over to Jenkins, we can see that there's a custom Helm values entry that's actually included, along with a persistent volume that's used to persist the data. These 2 files are referenced when we click on the editor option, and then we can see what files are associated with the deployment. Shown below are the chart name, the chart version, and the deployment files.